everyone, my name's Dane. In this video, we're going to be looking at how we build an asset model. But first, what is asset modeling? Well, it's asset knowledge captured in a specific framework that can be understood by both humans and machines to inform decision making. Now, this is different from, say, reliability-centered maintenance or machine learning, because asset models contain the causal thinking of subject matter experts, which make it multidimensional and dynamic. When we build the model, we're not just looking at any one particular asset, but rather at a higher level of what's important, why, and how each operational, conditional, and asset-specific variable affects each specific asset. This allows you to query the model and ask the more important what-if type questions. What if I replace this early? Or what if the demand or loading on the asset increases? Or what if the environmental conditions get worse? Enough talking. Let's get into building an asset model. A first pass asset model takes roughly 4 hours to build. For this walkthrough, we're going to be looking at sewage pump stations for water utilities, and it's sped up quite a bit. Typically, models are built at an asset level, think pump or motor, but we can also build them at facility or system level, and even component level. This model is a system level model. We start by facilitating the model with the relevant subject matter experts using a shared whiteboarding tool. In this case, we're using Miro. The idea is to get all of our thinking down on a single page before transferring it into the final model structure. We start with the possible components, their functions, and how they can fail. This is the superset for all assets within the system or class or component, depending on which level we're modeling at. We also assign probability distributions to each of the failure modes, which can be adjusted based on the context of the asset. Then we dive into the causes. We look at and discuss what causes a particular mode or branch of the component tree to be enabled. For example, different asset configurations, different makes, different build qualities. We also look at what causes the failure parameters to change. For example, different operating environments, loading or duty. And we look at conditional information, for example, condition assessments, condition monitoring, and what defects these can find, and what that means for the asset. This process gives us a good idea of the inputs that the model may require. What variables can we feed with actual data, and what data we may like to collect in the future, since it has causal links to the asset performance. We try to keep the inputs generic enough for all users, so some mapping between your data and the model inputs may be required. These inputs allow us to add context and derive a specific asset from this broader asset model. I'll show you how this works in just a second. We then go over all of the possible tasks. These can include interventions as well as inspection and condition monitoring tasks. Each task is linked to the elements of the structure that they affect. For example, an inspection may detect the presence of some failure modes but not others, and a corrective replacement task for an impeller may replace seals and impellers but do nothing for the corrosion modes on the pump casing. We then look at the possible events and what we want to track, mainly failures and executions of plans. We link these events to the relevant failure modes, the relevant plans, the relevant costs, and the subsequent tasks. Next up is costs. Each event is given a default cost that can be either overwritten for each asset or contextualized using the inputs and causes. These costs can include labor, parts, and materials, but also things like monetized risk cost, for example, safety, stakeholder risk, environmental risk, etc. While this model build is ongoing, all the references, images, and links to other material, anything else of use, can be pasted around the outside of the whiteboard for all the collaborators to discuss. After agreeing on the facilitated information, we then migrate this over to our application, and it looks like this. Here we can see all of the facilitated components, modes, causes, inputs, tasks, events, and costs. We also have to code any required formulas, for example, corrosion rate calculations, into the cause layer. The result is a multi-dimensional model that accepts inputs to generate specific assets out in the field. For example, if I specify that I have a 2-pump variable speed drive driven sewage pump station, and let's say it's in a high hydrogen sulfide environment, then the resultant model has been adjusted for this context. As we can see, 2 pumps, VFDs included, and the failure characteristics have been modified for the high hydrogen sulfide environment. We then go through and test that the behavior of this model aligns with the facilitated understanding. Once the model is built and tested, updating and improving the asset model is trivial. New components, causes, and updated thinking can be added and tested at any time. Notes and revision histories are captured, and the model is revised to a new version. Well, that's it for this video. I hope you got something out of it. I hope you like the content. If you do, please hit the subscribe button and like the video. It helps me out a lot. If you want to see something in particular, drop it in the comments below, and I'll catch you in the next one.